Okay, so you should have something that looks like this now that you have set up your spreadsheet. And now we're thinking about potentially setting up a comparative study that looks at do bands sell more albums than solo artists or vice versa? And so you need a way to split up your data. A good way usually to split up the data, you can think of the sleep study. They did less than 8 hours of sleep and greater than or equal to 8 hours of sleep. A lot of times in IB Math studies, I see students break up their data based on the overall median or the overall mean, because both of them are measures of central tendency. In yesterday's class, we decided to use the overall mean, so I'll keep things consistent and do that here. So we're going to have this category be less than 32 million albums sold, and this one be greater than or equal to 32 million albums sold. And again, I chose to make this greater than or equal to, that's also what the sleep study did, but you could have said less than or equal to 32 million and then strictly greater than 32 million. So if I go into my purple categories, I'm going to count the number of artists that had less than 32 strictly. 1, 2, 3, 4, 5, 6, 7, 8. There were 8 bands that had less than 32 million albums sold, and there were 1, 2, 3, 4, 5, 6, 7 that had 32 million or more, and we're a total of, I should have 15 total. That would be some. For the solo artists, I'm looking for artists that had more than 32 million albums or equal to 1, 2, 3, 4, 5, 6, 7, 8. So that would be 8. And then this would be 1, 2, 3, 4, 5, 6 for a total of 14. And that makes sense because there are a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 solo artists. So here, since it was a median, I would expect it to be half of our total. And that makes sense, 14 and 15. And now I'm saying, okay, was there a major difference with one of these outdoing the other? And if you look at it, there really is not a big difference here. So we are not expecting a massive chi-squared value, and we're expecting a really low a higher p-value. So if we go online, and because it's a 2x2 table, we're going to use Yates. So I'm going to type in online Yates chi-squared to go run our chi-squared test. So here's our 2x2 table. For our table, we have 8, 6, 7, 8. 8, 6, 7, 8. 8, 6, 7, 8. I'm running a chi-squared Yates. Calculate. My chi-squared is equal to 0.037, and my p-value is 0.8475. 0.8475 and what was that again? 0.037. And you'll notice my decimals are off here. Whenever your decimals are off and things aren't consistent, what you can do is highlight everything you want to be consistent and make sure that you're using these buttons here to keep everything consistent. And so I want more decimals shown in my chi-squared and my p-value. So I can just go up here and add a few decimal places. So that is where the last class finished up, confirming that you have a table that looks like this, and your exit ticket with Miss Morrison is to explain how to interpret this p-value right here.